Okay, thank you. So, good afternoon, everyone. So, we will continue our learning for genomic computation, bioinformatic computation. So, last week we learned about some features in Galaxy. I think this week also still Galaxy. And the following weeks we will change to maybe SnakeMake. It's another Python library. And also continue with next flow. So we will have more session with more library tools and framework. So why we do that? Because some framework provide best practice, predefined workflow, and also you can reuse, reproduce instead of you redo from scratch. Okay, so we want to make sure that you guys can reproduce as many as previous works, so you don't have to reinvent the wheel. So you can utilize many frameworks from TerraBio GATK. You can utilize Galaxy, then its ecosystem. You can find papers in bioarchive and reproduce if they are using Galaxy. If they are still using SnakeMake, you can also reproduce. And if they use the new one, Nextflow, you can also reproduce. That is the goal of this course, to equip you with enough tools and pipelines and framework so you can explore amazing area of bioinformatics and genomic computation. Okay, so before we continue with Galaxy, I just want to remind you that Python have a lot of features. Okay, initially I introduced BioPython, and I hope you can start use BioPython to download data from NCBI or EBI or DDGB, all of the public GIM bank data. So once you got the data like FASTQ or FASTA, yeah, or file like SUM or BAM or ECF, and then you can start to manipulate. So the BioPython have many features that I hope you can learn, not just skip it. But a lot of things you do with bioinformatics and genomic data is actually to do some sequence operations, right? Like here, if you get the BioPython books, you can see what you can do with the sequence object, okay? You can make it as a string. So sequence is ATC, GAC, all of the character level sequence. You can operate it as like a string. You can slice. You can turn sequencing object into string, concatenate, changing the case. Yeah, you can find nucleotide sequence, reverse the complement, do some transcriptions, translation, making translation table, comparing object, sequence object, okay? Sequence with unknown sequence content, you can analyze inside the sequence, find out which one is unknown sequence, because some sequence is already known from many database. You can find the unknown one. You can do mutable sequence object, finding subsequence, finding similar sequence. All of these features are available in BioPython. So you have to make sure that you have make your hand dirty and then copy paste this to your collab and experience the features. Okay? Because without experience the features, you cannot prompt, and without experience, you don't know what to prompt. Okay? Don't memorize the operation, the facility in the library, because let the ChatGPT or Gemini memorize for you. Okay, but a lot of features here. So I just want to brief you what you can do with this library. Okay, because I have limited time, I just want to focus on show you this table of content. Okay. So in chapter 3, you will learn about how to manipulating sequence like a string. In chapter 4, you can sequence annotation. You can annotate the object. Okay. So like you can create sequence record object. You create a sequence record. Yeah. And then you can annotate features, location, and position of the object. You can compare, you can make reference, format, slicing, and report. Okay. So all of this process is like annotation process, just like if you're thinking of imaging, medical imaging data set, you get the image, you annotate. Yeah. So just like that, but this is for genomic sequence. Okay. So in chapter 4, this is all about capability of Bioinformatics to do some sequence annotation on the sequence object. Okay. In chapter 5, you will learn about sequence input and output. Okay. So if you have sequence I/O, input and output, after the input, you have to parse the sequence. Yeah. So, or you read the sequence. You read the sequence file, iterating the report in the sequence file, getting the list, extract the data, modifying the data. So all of the I/O operation is explained in this chapter, including parsing, okay, reading. You can parse from the compressed file. You can parse from the net. You can make sequence file as a dictionary data structure, like dictionary in memory. So you can do more if you put that in the dictionary, and you can write sequence files. Okay. And also it teaches you how to do low-level FASTA and FASTA parser. Okay. And chapter 6 about sequence alignment. So you have sequence object, you want to align the object, like create alignment object from sequence, and then align their attribute. Okay. You can do slicing, you can do operation alignment, reading and writing alignment, and many more. Okay. And next you will learn pairwise sequence alignment in chapter 7. And then chapter 8, multi-sequence alignment object. Okay. And many more, all of these features. Okay. So because it's so many features in Python that we cannot memorize everything. So make sure you have scanned all of the capability. You have copy paste the code so you can see how it works. So when you do the code-based prompting like SnakeMake Python, yeah, or Nextflow. So SnakeMake is based on Python. Of course, it will powered by many libraries like the by Python, yeah. So many bioinformaticians using SnakeMake, 11 new citation per week, yeah, old plus new paper, almost 920,000 downloads already. Okay, so it's very famous. So later after Galaxy, we will go into this, but I just want to make sure before we go to SnakeMake, you already know the features and capability of Python. So when you do workflow in SnakeMake, you know what is the basic operation in Python. Okay. And later we will learn about Nextflow. Nextflow is another workflow engine that is also very famous currently, very active. Usually in Spain, in Barcelona, in US, in Europe, they have many community. And hopefully we can create also Nextflow community in Indonesia. So all of the research around the world is contributing to Nextflow workflow. Yeah. So they publish the workflow in NF Core, NF refer to Nextflow, and they have many pipelines available. Currently, there are 104 pipelines. Okay, and you can just search like a functional scan, metagenomic. rare disease called pangenomic, NASAN. Oh, a lot, yeah. So instead of we are trying to make the pipeline for specific use case, usually the best way is to reproduce the pipeline in SnakeMake and also in Nextflow, and then try to see what kind of modification, let's say for data pre-processing or for data post-processing, that you can do to adapt your data to the pipeline tasks. Okay, so we have to learn this in catalogical way, means that you have the catalog of as many as catalog of pipelines that you can get from the community, and then you structure your catalog. So if you have any tasks, and then you can go back to your catalog and then find out where you can get started. Okay. Okay, so for today, I just want to show you this BioPython that it has many features. So I want you to manage your time by yourself, copy paste chapter 3 up to chapter 14, I mean more, maybe chapter 24, yeah? 24 is not necessary, it's about the contributing to BioPython, yeah? But maybe 23rd. If you do it diligently, one chapter per day, yeah, just copy paste, read the documentation, yeah, you can download documentation in PDF or copy paste from this HTML. Just prepare your Google Colab, copy paste one by one, make your familiar, and always try to open this ChatGPT to test the hallucination in ChatGPT if you command ChatGPT to do the same. Yeah. So let's say here, yeah. Once you understand these features, and then try to make ChatGPT from the example of the code. Like for example here, let's say my sequence is here, and I want to make it as a string and then do some string operation based on that. Okay, I can say to ChatGPT, or you can say sequence, make write Python code, write Python codes to make it as string and perform some operation string using Python. Okay. So during your copy paste, you can start to see. So you don't have to memorize. Okay. So if you do that, I believe you can learn maybe 10 times faster compared to people who don't do that. Yeah. Any time that you spend, any energy that you spend during your learning process, it's worth, yeah, because this field is really, really impacted by AI. So many things will happen from digital biology, not only on software side or maybe robotic side, but Gen AI will also impact bioinformatics, genomic, and life science. So I hope you do that as your homework. Set your schedule to learn about Python day by day. Maybe I think 2 chapters per day is enough, like 1 hour copy paste. But after that, you can really master the BioPython library because it will be useful when you work with code-based framework like SnakeMake and BioPython later on. Okay, so that's all from me. I will hand over to Padin and Kalbe Digital Lab interns. So you can see some reproduction or you can learn more from Galaxy and also other frameworks like Nextflow and SnakeMake in the following weeks. Any question before I hand over? Okay, if not, please Padin and who, please continue, yeah?
Okay, thank you so much, Mr. Risman, for explaining about BioPython. I will continue to introduce to about Galaxy. For today's lesson, we will learn a few things about Galaxy workflow, Galaxy publication, and also about Nano Galaxy. So today we will learn about the first step is introduction to public workflow in Galaxy, and then we will run existing workflow in Galaxy. The third part, we will search about Galaxy publication library, and there will be a paper explanation about nanopore, and the last one is about nanopore reproduction in Galaxy. So for the first step about public workflow in Galaxy, my intern will introduce about it. Selfie, please go ahead.
Okay, thank you, Kak Fadian, for the introduction. So today we will continue our tutorial with Galaxy about how to reproduce public workflows in Galaxy. We will share screen. Okay, so before we begin, let me introduce public workflows in Galaxy. So maybe you can access this link. I will share the link in the Zoom chat. I'll share the link about Galaxy public workflows and Galaxy main server. Okay. So these public workflows are pre-built analysis pipelines created and shared by the Galaxy user, and they allow us to leverage existing workflow for our analysis instead of building them from scratch. And of course, this can save a lot of time and effort, especially for complex analysis. So now let's head over to the main Galaxy server in usegalaxy.org, or you can click the link in the Zoom chat. So this maybe I will sign up first. Okay. So you can either log in if you have an account or register for a new one. So I will log in. Okay. All right. So once you log in, you can go to the top panel here and click on workflow. So here you will see three options in this our workflow and workflow share with us and public workflow. And then select public workflow since we want to reproduce a publicly shared workflow. And then this is you will find many workflows created by the Galaxy community, and there's so many workflows. And then we for this tutorial let's choose next generation sequencing. This workflow, and then we click import button here, and this message we will receive success message here, and then we next click on the workflow panel at the top and here, And this is the workflow that we success imported, and we choose the edit workflow here to view the imported workflow. And this is our workflow. And this workflow consists of the following steps. For the first one, this input step, you can input your FASTQ file, and then the second, this is you can click here. So this is FASTQ sheet tools. We will use these tools to generate a quality control report for the input read. And then in the left panel here, you can scroll down to help section here. It shows as detailed overview. You can set the possible option you can see in here. And the third one is Trimomatic tools. We will use this tool to trim for quality read. And then we will use this tool to perform our alignment. And this tool name is HiSet2. You can also see more information on HiSet2 in here in help section here. And then this SAM tool, sort tools, we will use this for sort the alignments by left modes coordinates. And then this FastQC tools after trimming for generates a quality control report for the trim read. All right, to run this workflow, we can click the run button here in the top left corner here. We can run. Okay, so this is you will need to provide an input FASTQ dataset. So you can either upload your own data by clicking upload data in the left panel here, or we can use a shared dataset from Galaxy's data libraries. So for this tutorial, we will use a shared dataset. First, we go to the top toolbar in here and click data. Choose data libraries. In here, you will find dataset shared by other Galaxy user, and then you can select the desired dataset, and we can select this chip sequence mouse example, and then we select the first one, and we choose add to history button here, select as dataset, and either select an existing history here or create a new one. So let's create a new one and name it yes. And click import to add dataset to your history. We will receive this message and we can click here to start analyzing it. We click here, and then we'll have the imported dataset here and our history. And now we can go back to the workflow panel here on toolbar, and we click run workflow again. And we select this imported dataset to our input FASTQ file and run workflow. So this workflow have 5 jobs to complete. We wait for the analysis to complete, And then as we can see in the left panel history here, we can see there are three colors, gray color, yellow, and green. So this gray means that the process is in a preparing or queued state. And this the yellow means that the process is currently in running state. And the green here indicate that the process has been completed successfully or has reached a success state. So we can wait for a few minutes to be done, and then there we have it, the output from the tools in our workflow. And then first you can inspect the outputs by clicking the eye icon here next to each output dataset. So maybe for the first output from FastQC tools, there are two outputs, and we can click the eye icon here, and this show quality control report for the input reads. And then for the trigonometric output here, we can also click eye icon or the pencil icon to edit attributes or see the information about the output file. So this file shows the number of input reads, and then surviving reads, and drop reads. Okay, and the next is output file from alignment tools or high set to output. So this line reads in BEM format, and then you can also visualize this output with icon here. You can click, and then we can visualize it at UCSC Genome Browser or other visualization tools. Maybe this display at UCSC Genome Browser, you can see here. And then the fast QC output after trimming, we can also see the quality control report for the trim reads. And this is also allowing you to compare the read quality before trimming and after trimming. So we can compare the read quality. And then for the last tool is output from SAM tools. This sorted alignment in BEM format, and which you can also visualize this at UCSC Genome Browser or other tools. Alright, so that's it for the tutorial on reproducing public workflows in Galaxy. Maybe we can now continue our lesson with Kak Fadin. Thank you.
Okay, thank you so much, Sylvia, for explaining about introduction how we can reproduce existing public Galaxy workflow. If you guys have any question, please don't hesitate to ask in the chat chat box in the Zoom. I will continue to explain. Let me share my screen first. Okay, and I will also send the link. Okay, So Galaxy has this community hub and also have the Galaxy publication library that uses the Zotero as the bookmarking services to organize publication that reference Galaxy. You can search the library at Zotero or through the unified Galaxy search. If we click on this link, it will redirect you to the Search the Galaxy webpage. We can search in here related tools or topics about biology, bioinformatics that you would like to see in the publication. For example, if I type in the nanopore, and there will be two results that will pop up. First is the pan-galactic Google search, which contains of the code-based Galaxy and other related projects, and the forum, etc., and also the Galaxy publication search. In this Galaxy publication search, powered by Zotero, it is isolated to the Galaxy publication library. So if we click on one of these links, it will redirect you to the original paper about Galaxy. We will go back to the first pages about the Galaxy publication library. In this web page, you can search on the Galaxy about the publication using the specific text. These texts below specify how each publication relates to the Galaxy projects, where they are manually added to papers when they are added to the group. And every publication should have at least one Galaxy-specific tag, and publication can have more than one tag. For example, here there are a bunch of tags like cloud, education, how to related, how to use Galaxy for specific analysis, and then publication about Galaxy with tag is Galaxy, the methods uses Galaxy in their methods, and also the tools, the visualization, and the workbench. For this tutorial, we will choose the tools tag, which allows us to see the publication about Galaxy tools that run in, have been ported to, or interact with Galaxy. If I click on this, then there will be a pop-up of list that related to the tools that are already been published about in this each paper. And you can order it by date or order it by the creator, and also you can search what kind of tools that you are looking for in this publication. Like for example, if I want to search about the nanopore technology, I can type in here. And there will be tools that use in each paper, for example, in this paper, and we can double click and it will redirect to the original paper. So about nanopore, if you guys didn't familiar about the nanopore, it is a nanopore sequencing solution which can make sequencing accessible, where you can sequence your samples and analyze your data that comes from the output from nanopore technology. It is powered by Oxford Nanopore Technologies. It is pretty popular in the market, and many people use these technologies to sequence their samples for the long read samples. Okay, so back again into the paper. Here you can click the PDF icon and it will redirect you to the paper. Okay, so this is the paper about Nano Galaxy, nanopore long read sequencing data analysis in Galaxy, where they developed new Nano Galaxy, which is based on or powered by Galaxy for analyzing long read sequencing data, which is suitable for diverse application, including genome assembly, genomic, metagenomic, and plasmid sequence reads. If we scroll down, you can see many tools that have been ported to the Galaxy platform. such as the category genome assembly, long-read mapping, quality control, pre-processing, visualization, taxonomy, metagenomics, and the last one is varia calling. You can find all these tools below in the Galaxy project. And also there are some workflows that they are developed and make it public, such as metagenomics taxonomy classification, which is for the taxonomy classification using Kraken 2 tools that utilized for the long reads, and also you can find visualization about the pie charts using the Corona tools. And if we go down, you can also see the workflow available. There are 4 types of workflow. The first one is basic workflow inspired by the nanopolish. The second one is genome assembly, and also the third one. And the fourth one is the metagenomics. You can click on this link below. You can choose either one of them, and also you can choose the history to copy into your own Galaxy. For example, if we click on this, it will redirect you to the nanopore server. And you can click import workflow, and the workflow will be ready to use, and you can use it on your own account. Start using these workflows, and you can use it by run it and using the history also. If you click this history link, and you can import it also like the workflow before. And for the Nano Galaxy, you can click this link on the Zoom chat, and here you can find a list of directories, servers, clouds, and deployable resources that utilize Galaxy. You can click on the all, and you can see many kind of resources that use Galaxy as their server. And you can type in Nano, and you will find the Nano Galaxy server that it's used to process, analyze, and visualize Oxford Nanopore Technologies or ONT data and similar long-read technologies. If we click on this, we will see the workflow of Nano Galaxy, such as tools, quality control, assembly, alignment, prediction, and visualization. And also, this is the domain specific for the Nano Galaxy. You can click in this public server link, and it will redirect you to the Nanopore Galaxy server. Here we can find the getting started and also the tools, the tutorials that populate in Galaxy Training Network. You can find it if you click in here, and also the workflows. If you guys remember, there are 4 workflows in the paper, and the workflows is available all in here. You can utilize it like Selfie did before with the public workflows. You can also use it with the Nanopore workflows. That's it for the Nanopore introduction and also for the Galaxy publication. We will continue our learn to reproduce Galaxy, Nanopore tools, and many kind of tools that available on Galaxy with Haikal.
Thank you, Kak Fadil, for the explanation. The following are improved and modification to explanation for the identification of microorganisms in B using nano sequencing. First, we open the Zoom link to access nano galaxy specs. I will share screen. Before starting, let's first view the overview section. Then click to overview. After that, display will appear described. Intermediately, we click import to download. We choose to server Galaxy Euro. Europe. And then upload to data. Data have been uh, for the chat to Nando, and copy data faster. Uh, we process. We cross to the step, and then I will show done process. I will show done process. If you then if you're not we are not able to enter tab and we're not able to upload data. Once finished, I will explain for identification methodology we're using nano sequencing the following example interaction for the flow. It is the flow is microorganism beer using nano sequencing. In the sequencing data analysis, can we first key have the access raw data quality in the T5 potential specific material. And then finally, corona visualization present to taxonomy result in an pie chart offering to overview of the sample microbiology, useful communication, and publication. I will show to one pie chart to corona chart. Is this plot by following the narrative for this pie chart, corona depict the taxonomy organism focus the population to specific for different group. Highlighted the bacteria dominal, accounting for 914.3% of the species. Follower and by Fugi 6%. Then further details such. However, this figure does not indicate all biomass, but one to purpose to species. The motto of the diagram is show species in taxonomy context in a simple visual way. There enough my explanation. I come back to Kak Fadil.
Okay, thank you so much, Haikal, for explaining about the nano galaxy, nano for reproduction. If you guys have any question, please let us know. And without, please comment in the chat if you guys have some questions. So for the keynote about what our for today's lesson is about, the first one is we already know how to run the public workflow and run the existing workflow, and it will save a lot of time because we can reproduce it and we rerun it with different kind of samples. And the second of all, we can search about the publication in the galaxy and search about the related in the public servers for the nanopore in the nano galaxy. And the third one is we learn about how to reproduce the nano tools in the galaxy in the topic about microbiome in the biodata analysis. Okay, that's it for today classes. Hope you guys learned a lot for today. We will continue our lessons next week about SnakeMake, and happy weekend. Thank you so much for attending this class.
Thank you. Happy weekend, everybody.